Hello everybody, welcome to this video. This is part 2 of my cloud architecture series. I really apologize for today. This video should have been released yesterday and unfortunately I didn't get it completed in time, so I really apologize for that. But I'm really excited to continue on this series. I really enjoyed the last one and I hope you guys did as well. So cloud architecture, there's a lot to get into and there was things that we didn't cover. And so let's carry on where we left off. So it's the blueprint again for you guys to look at. So in the blueprint for the CCNA, it talks about explain the role and function of network components, servers, and then describing the characteristics of network topology architecture, so on-premise and cloud. You know, you've got, especially when it comes to cloud, there's different topologies for different types of connections. Now we'll be looking at them in this lesson. And virtualization fundamentals. So we did start that, server virtualization containers, we looked at that. But now in this video we're going to look at, we'll have a look at IaaS, PaaS and SaaS, infrastructure as a service, platform as a service, software as a service, looking at the different tiers of cloud, these different cloud service models. And then we'll be looking at virtual router and forwarding as well, which is something really exciting. So yeah, there's quite a lot to cover. However, what I wanted to say was, in terms of the breakdown, in this lesson, we'll only be doing private public cloud, having a look at those two, IaaS, PaaS and SaaS, virtual router and forwarding, enterprise-wide connection to the public cloud. We'll have to leave it there, and then there'll be a third video. I didn't originally plan this, but look, I think I need to have break it down in two separate videos just because of how much there is to cover. So I'll have a third video. We'll be looking at cloud management, and then final takeaways. So we'll be looking at everything that we've covered in those three videos for cloud architecture, and then I'll mention the key points, takeaway from those from the videos, and then we'll have a quiz as well, so you can test your knowledge. So yeah, a lot to cover, is really exciting. So let's look at public and private cloud first. So it's important to know the difference between these two terms, right? Not to get them confused. So private cloud, this is resources, cloud computing resources that are used exclusively by an organization. For example, like I used in my last lesson, Buckingham Vale Grammar School. Okay, so it's a fictional school in England, but this is an example of an organization which could be using a private cloud. If they use a private cloud, that means those resources are either located in their own data center, that school's data center if they have one, or hosted in the cloud by a third party. But the thing is, those resources are used exclusively by them. It's not like a public cloud where you could have a rack of servers and you could have 5 or 10 different customers using services that are in those in that physical rack of servers, in that physical rack, even on the same server, even on the same actual physical server, but because the services will be sold, will be sold as virtual machines or containers. You won't know that who's got another virtual machine. If you got Enterprise 1, they won't know about a virtual machine, another virtual machine being used, that same physical server used by Enterprise 2, because that's you have that beauty there with virtual with the public cloud, where these services are separated for the customers. They don't know where the services are actually physically running at in that data center, but it's very likely that you'll have another customer or a couple of customers or many customers actually using those same physical connected to the same physical server, but it doesn't matter in that sense. But private cloud means those resources are all owned by yourself, your own organization. Public cloud is different. It's managed by a third party, and they have many customers. Okay, you accessing those same physical servers. So you know, Google Cloud is a big example. Amazon Web Services is the biggest by far in the public cloud market. Still have the biggest market share last time I checked, and Microsoft Azure. So these are three of the biggest players, but there are others as well. So now let's get into IaaS, PaaS, and SaaS. Right. So these are concepts that are really important to know. IaaS, PaaS, and SaaS, infrastructure service, platform as service, software as service. It's very important to be able to differentiate between these different services, right? Because when it comes to cloud, there isn't just one type of cloud service. So commonly you'll hear of these terms. You might hear of other terms as well, but these are the three that are commonly used: infrastructure service, platform as a service, and software as a service. infrastructure as a service, platform as a service, and software as a service. These are the three that you'll commonly hear about, and it's important to actually know what these terms, being able to understand these terms. So I'm going to bring out the whiteboard because I think the whiteboard always helps to have good visual, get a visual understanding of what these terms actually mean. So just getting my whiteboard out, and we'll take a look on the whiteboard. Sorry guys, I'm still here. Just bear with me a moment. Okay, I apologise for the delay there guys, apologise for that. Let's get into the next slide. So infrastructure as a service is going to be the first one. So infrastructure as a service, this is where the organisation will have the most responsibility, and the cloud service provider has the least responsibility, because the enterprise has responsibility of the applications. They will have they'll have responsibility over that side of things. So the cloud service provider does the least here. They manage the least. But the different use cases, of course, for different types of services. So let's get the whiteboard out. So here's my whiteboard, and let's get that a bit closer up there. So what we need to just getting in position. So, right, okay. So for infrastructure as a service, what we have is you have your storage, the CPU, you have the RAM and the network. You have your operating system on top. You have applications. But infrastructure as a service, what's actually happening? Well, the customer can choose how much they can pick the operating system. So you can have Linux, you can have Windows Server, and you can pick that. You can you can choose. You can install whatever applications you want. You have you have control of what applications you want. You can install, decide whatever you want to run. If it's whatever relating to the enterprise. But it's all about control. What's actually happening? Who's controls what in this type of service? Well, might be. What I'll do is 1 second. Sorry. Sorry guys, just bear with me. apologize for that, guys. So yeah, so infrastructure as a service, basically you have you have these resources here are virtualized. Your storage, your CPU, your RAM, network resources. Remember I was talking about virtual machines in the last video. So our virtual machines enable us to basically divide how much storage and CPU and RAM and network each virtual machine will have. And that's great because it ensures that we don't we are not underutilizing our resources. But its infrastructure service is great, but like I said, is the most responsibility on the customer there, because they manage the most in this situation. If we move on to platform as a service, let's move on to platform as a service. So platform as a service, whenever I think of platform as a service, I always think of developers, because this is really for developers to run their tools on. So it's kind of a bit similar to IaaS, but here what we have is developer tools, and as the name suggests, it's really useful for developers. So when it comes to platform as a service, our developers can run their software tools, and so this is going level above just the basic operating system, and this can be useful for actual testing, sandbox testing, and it's, if I draw it out, so here you have your dev environment, and your tools as well, running on top of the operating system, and then storage, CPU, RAM, networking, and finally talk about software as a service. Now, software as a service, I'm sure everyone watching has interacted with software as a service. Software as a service means the customer has the most responsibility, and when it comes to software as a service, and nowadays our emails, our CRMs, our banking, those of you who have iCloud accounts, and these are all examples of software as a service, all examples of software as a service offerings, and it's brilliant because the consumer is getting a service with a software service, but they don't have to manage the infrastructure, they don't have to manage the actual servers or even the operating system. You're just interacting there with the actual software, and it's the least maintenance for the consumer to do, for the enterprise to do. The cloud provider will do the licensing. So let me write out, this cloud service provider, the CSP, will do the installation, the maintenance, upgrades of the software, of the operating system, all this, all this maintenance is done by the CSP. CSP's responsibility. So there's a responsibility there of the cloud service provider. So it's great that we have software as a service now. It makes it so much more easy for enterprises. to run their business applications. So let's go on to the next slide. Virtual routing and forwarding instances. So VRFs are awesome, but I'll tell you why. So public cloud providers like Azure, Amazon, they need to support multiple customers concurrently. However, there's an issue, and what is the issue? Well, when it comes to a router, when it comes to routers, right, and enterprises many still use IPv4 private addresses and for their devices, and that means we have millions and millions of enterprises, if not billions, using the same the same private addresses in the organizations. And so when we bring them into the cloud, their devices and even the virtual machines in the public and private clouds are using those private IPv4 space addresses. So does this mean every customer needs their own router if they are using their own? If every enterprise or if many enterprises are using the same overlapping private IPv4 addresses? Thankfully, no, because virtual routing and forwarding helps us here, because it creates virtual routers, multiple virtual routers inside a single router or layer 3 switch. And as VRFs support and operate, as VRFs operate IP routing an IP routing table per VRF. Every VRF has its own routing table. The router can support overlapping subnets, and our MPLS providers that rely heavily on VRF to support hundreds, even thousands of customers, they can do this because it's been powered by VRF. VRF enables this to happen. Okay, they don't have to buy one router for every single customer, because that'd be ridiculous. But you got to remember that when it comes to routing tables, when you count routing tables, every VRF has its own routing table. There's a global routing table as well. So if you were ever to calculate how many routing tables you have, it's the number of VRFs plus the global routing table to give you the total number of routing tables. Now, please remember this: you cannot have two layer 3 interfaces in the same subnet. When it comes to VRFs, you can't have two layer 3 interfaces in the same subnet. If you do, the router is not going to bring the second interface up. Okay, enterprise WAN connections to the public cloud. So let's look into this now. There's different ways of connecting to a public cloud, right? There are different ways we can connect, and the public cloud is awesome, but there are different ways to connect, and we need to know that these have pros and cons with them. So public cloud is easy to work with because it leverages the internet, and this makes the onboarding process easier. And that's what we call agility. And the migration process also becomes easier. And for remote users, because they're already using the internet to access access the enterprise's network and to be able to access whatever they need over the internet, it's easier for them to access the public cloud and with fewer complications than the private cloud, as they already need the internet to work from home or from wherever they're working. But when it comes to disadvantages, what we're looking at: security, because the internet is less secure than having your own private WAN connection, or having a VPN connection. It's a VPN tunnel. The internet is just less secure. It's just by its nature. Now, there's no quality of service. You've got to remember this. And also, when it comes to internet VPNs, no quality of service, because you can't control internet traffic. You can't. It's the Wild West. You cannot control you cannot apply quality of service rules when traffic goes into the internet. There's no WAN SLA. So unlike private cloud, public cloud providers, our ISPs, will not provide WAN SLAs the same way they do for private WAN services. We just can't expect that. And capacity is also more a disadvantage and kind of a consideration, I'd say, because we need to ensure that when we point more traffic on, when we're embracing the public cloud, when we are onboarding with the public cloud, that our internet links can support that additional traffic that will be going over them. If you're using a SaaS application, software as a service application, for example, an organization was going to do away with, for example, an internal, an internal accounting server that was hosted in their own data center, and go into and use a public cloud software as a service accounting system. They'll need to ensure that they have the bandwidth to so that it can cope with that. Otherwise, that could be an issues, performance issues, and we don't want service degradation. So let's look into Intercloud Exchange. Now, Intercloud Exchange is awesome. Intercloud Exchange is something just brilliant, and because it makes the process easier when it comes to when it comes to, if you want to switch, like I was saying, when it comes to migration, it makes migration easier. Okay, it's a dream for cloud, for public cloud migration, I'd say. And there's different players who can provide this. One example is Equinix Fabric. They have an intercloud solution. So I'd say it's a dream for public cloud migration. And why it is, for example, you've got an enterprise here. So let's call this New York City Enterprise, Enterprise 1, okay? Now, this is an enterprise in New York City, and they currently use a service hosted in, they're currently using Microsoft Azure, but for cost-saving reasons, they want to migrate to AWS. And normally, if they wanted to do this, it would be quite difficult. It's a difficult process to switch from Azure to AWS. Migrating public clouds, unfortunately, is not a piece of cake. So this would be difficult. However, if you had an intercloud provider, what the intercloud provider is all about is, this is an organization, is an organization which has connections already. They have connections established with these cloud providers. Okay, so they make the process easier because of this. They connect to multiple cloud providers, and then they on one side, so on this side they connect to cloud providers, on the other side they connect to enterprises, and so it won't just be AWS and Azure. They could have, for example, Google Cloud as well. So Google Cloud, they already have connections set up with them. So if this New York City enterprise goes via the intercloud provider, it'll be easier, because it's just a matter of, for them to change the WAN links from Azure to AWS. We need to configure the private WAN connections to AWS now instead of Azure, and okay, so it is a reconfiguration. It's a reconfiguration to set up the private WAN connections to this cloud provider instead of this one. So it's awesome in that it makes the job easier. Okay, so it's a matter of reconfiguration. Okay, reconfiguration. So that's intercloud. Now, next up, private WAN and internet VPN access to public cloud. Okay, right. Private WAN and internet VPN access to public cloud. So let's discuss now private WAN and VPN tunnel. So if I bring back that New York City Enterprise 1 in New York, and let's say, okay, these guys have a connection to, let's say, Microsoft Azure. instead, now before we looked at intercloud, but let's talk about other different connections, right? When it comes to private WAN, not public this time. We're talking about private. So, sorry, what I meant to say. Let's look at private WAN and VPN tunnel connections. So, because these are another two options. You can have a private WAN connection or a VPN tunnel connection. So when it comes to private WAN, an Ethernet WAN connection, to be more specific, what would an Ethernet WAN connection be about? Basically, if you remember from the last lesson, I talked about something called EVC. Now, EVC means Ethernet virtual connection, and this enables E-line, and that's that. And so, if we wanted to have an Ethernet WAN connection, an EVC would be created to facilitate this, and this has advantages to it. It's advantageous because we've got to remember with these different connections, there's advantages, disadvantages to them. But an advantage of this one is that this supports QoS, so quality of service. Unlike with public cloud, with using an internet VPN or using the public cloud over the internet, this connection, this type of way of connecting to a public cloud, supports QoS. It supports quality of service. Okay, because this is a private connection. This connection is private. Now, when it comes to internet VPN, those aren't. It's not the same. You can't control the traffic. Here we can. So, quality of service would be something we can have that we couldn't have before with internet and internet VPN. Our data obviously is also private, so security is better in that sense as well. Security. So an Ethernet WAN connection is great in that sense. Let's look at we've looked at internet and connecting over the public cloud over internet. We talked about intercloud. We talked about Ethernet WAN. Let's talk about MPLS VPN. MPLS VPN. It's what's that? Enterprise there. NYC Enterprise. Sorry, that's a New York City Enterprise there. Cloud again, but this time we have MPLS VPN. Well, MPLS VPN again. What we have now, instead of we won't be using an EVC this time to facilitate the connection. Instead we have in an MPLS VPN. And this is great. Again, we can have quality of service because that connection is private. It's a private connection, and that's awesome. Now remember, MPLS VPN doesn't mean that the traffic's necessary. Remember, when we say VPN, that doesn't always necessarily mean the traffic's encrypted. And I think MPLS VPN, if I remember correctly, that doesn't necessarily mean the traffic is encrypted. Although that can providers may offer that. Just to keep in mind that it doesn't necessarily mean the traffic's encrypted, but MPLS VPN is another way of connecting to the cloud. That is really good there. Now, finally, I'm just going to talk about just a internet VPN tunnel. Now, with an internet VPN tunnel, we talk about internet VPN tunnel. We have again enterprise. You have the cloud, and in between you got an internet VPN tunnel. How can we create a VPN tunnel? Well, what we need to have, also we need to have routing. Now, what we can have is a cloud services router, which is basically a virtual router running as a virtual machine. Okay, so a CSR, okay, a cloud services router. Cloud services router. And an example of this is Cisco 8000V, okay, and this is a CSR solution to enable you to have an internet VPN tunnel connection. Cisco 8000V series, Cisco 8000V or Cisco Catalyst 8000V, and this is an example of a cloud services router solution. Or rather, a replacement for the CSR solution. But you can have a CSR, a cloud service router, but the Catalyst 8000Vs really become a replacement of that. But as far as I know, CSR is still available. But these are other ways of connecting to a public cloud provider. So that now brings me to the end of this video. So thank you guys for watching. Hope you enjoyed this video. I'll see you in part 3, where we're going to be carrying on looking at cloud management, something really important, and particularly Meraki and the Meraki dashboard. And then we'll be having a quiz as well. So thank you for bearing with me. Apologize again for the delay in producing content, and but I really appreciate you guys joining me on and watching the video. And please like, share, and subscribe. And I'll see you in the next video. Thank you so much for watching. Thank you. Goodbye.